This is a base of the Strategic Air Command. Its purpose, to present a formidable deterrent to enemy attack. And, should such an attack occur, to ensure certain and lethal retaliation. Guided missiles, each ready for instant flight toward a designated target. Ground alert for bombers and their crews. Airborne alert. This activity is not just a military exercise. It is a necessary means for survival under the pressures of the Cold War situation. During the years of the Cold War, SACC reaction time to the danger of possible attack has been reduced from hours to a very few minutes. The essential element for holding SACC reaction time to a minimum, thus instituting effective command and control, is the ability to maintain second-by-second contact with the worldwide system of bases. The Strategic Air Command Control System, Project 465L, a man-machine complex designed expressly to fulfill SACC requirements for rapid message handling and visual display of vital information, will enable SACC to meet the imposed reaction times with rapid command decisions under any foreseeable conditions of the future. Problem: the reduced time available to carry out the command task coupled with its inherent complexity. Solution: automated assistance. Realizing its need, the Air Force instituted development of a system specifically designed to assist SACC with automated transmission, processing, and display of information. A system capable in its final form of presenting an up-to-the-minute symbolic picture of SACC status and of pre-storing the data for a complete war plan. This is the Strategic Air Command Control System. The task of designing and constructing a complex command and control system requires a large number of highly trained specialists. The prime contractor and system manager is International Electric Corporation, an ITT associate. System equipment is being developed under subcontract to IEC. ITT Kellogg and ITT Laboratories are designing and fabricating data transmission equipment. ITT Federal is responsible for the display equipment. International Business Machines supplies the data processing equipment. And Federal Electric Corporation is supplying maintenance and support services. System Development Corporation, also under subcontract, is performing operational analysis, computer programming, and organizational training and indoctrination. This building houses International Electric Corporation's prototype test facility. Here, at the earliest possible time in each stage of development, system equipment will be tested for operational feasibility. Following tests, SACC will be provided with an interim but fully operational system, a phase called Initial Operational Capability, or IOC. The final phase, Complete Operational Capability, or COC, will make available the full flexibility of the system under all conditions. Prior to IOC, a single computer will be installed at SACC headquarters. This phase, called First Operational Computer Installation, will provide assistance to planning operations and will help smooth the transition from the present system to the new one. Project 465L will result in a complete command and control system containing all elements necessary for SACC to meet the advanced requirements of the future, including those imposed by satellites and weapons in outer space. Three major subsystems provide the automated data handling capabilities that make the system unique: data transmission, data processing, and data presentation. The data transmission subsystem contains the automatic communications equipment and transmission channels that link the SACC bases to their numbered Air Force headquarters and to SACC headquarters itself. The headquarters group is the center of the communications network. At each headquarters is an automatic electronic data transmission control center known as an EDTCC. These are essentially switching and routing centers, tying together the subsystems into an integrated command and control system. An input-output station is placed adjacent to each of the 4 EDTCCs. This is called an electronic data local communications complex. At each SACC base, there is a similar input-output station called a remote communications complex, or RCC. The transmission control centers are connected by cross-tel links, and each link is duplexed. Each remote communications complex is connected to 2 transmission control centers. Since each link throughout the system is duplexed, the failure or destruction of any single link, or even of an entire electronic data transmission control center, can neither cause isolation of any element of the system, nor alter the effectiveness of command and control. To illustrate how the system operates, take the example of a message originating at a remote SACC base and addressed to SACC headquarters. The message content is typed on a standard form. It is then delivered to the remote communications complex for transmission. The message is put in digital form, error checking is added, and the message is encrypted. Now the encrypted message is sent over the primary link to the associated transmission control center. But the communications link is broken. Automatically, the message is rerouted through the secondary link. Upon receipt at the alternate transmission control center, the message is relayed to its addressed destination, in this example, SACC headquarters. At SACC headquarters, the transmission control center receives the message and, depending upon content, stores it or transmits it to its addressed destination. The vast quantities of input data received by SACC require rapid reduction and correlation. The data processing subsystem carries out this function. Data Processing Central, the brain of the subsystem, is a high-speed digital computer and its associated peripheral equipment. It is capable of more than 300,000 operations per second. It has a core storage of over 65,000 computer words, a magnetic drum storage of 280,000 words, and magnetic tape units that store large blocks of data. Under the control of an executive program, the computer performs control of operations, planning, training, and maintenance functions. Use of the computer in control of operations, for example, permits the information for identification and resolution of operational problems to be quickly processed and displayed. For planning, the system assists in data gathering, and the computer's ability to handle vast quantities of data will relieve the planners of laborious, time-consuming tasks. When the SACC control system begins its period of initial operational capability, the system will have only one central computer. With complete operational capability, additional computers will provide added capacity for automatic data processing. When information has been transmitted and processed, it must still be transformed quickly and accurately into visual display. This is accomplished by the data presentation subsystem. Large screen displays are updated rapidly. Wall displays show the current and predicted status of the SACC force. A central map enables controllers to follow an entire action as it occurs, displaying weather changes, routes, bases, and aircraft. The display room is arranged so that there is no interference in viewing. Projectors provide the screen displays, map outlines, and overlays. A 4-projector unit called a group display generator adds numerals, letters, and symbols in black and white or color. The displays used in control of missiles are typical of the large-screen tabulated displays. The missile status summary is present continuously in the operations control area of SAC headquarters and is kept up to date in accordance with the receipt of missile status reports. The missile launch summary appears whenever launchings have been scheduled. This display contains information for monitoring either ICBM or space vehicle launchings, providing the control personnel with both scheduled and actual launch data. By means of a request panel, an operator can instantly call up information not currently displayed, request computations to be performed, and relocate or terminate displays. High-speed hard copy printers are used for individual presentation of detailed information, thus providing a permanent record that can be handled and written on. All is planned to achieve best utilization of space, display visibility, and communications to enable SAC to make the most efficient use of the automated subsystems in carrying out its many operations. There are 2 essential elements to any military operation. First, a detailed plan must be made. Second, a means for control of operation must be devised to govern the execution of the plan. The tasks faced by Strategic Air Command in both areas, planning and control of operation, are multiple. The planning of any SAC operation involves many tasks and subtasks, each seemingly endless in its demands for detail. Such tasks might concern assignment of aircraft and crews, air and ground operations, support or selection of weapons, the planning staff must take into account force structure, the composition and geographical configuration of SAC units, and force posture, the particular alert status of the force. Planners must work out target assignments for missiles and bombers, and for missiles, trajectory computation. With the aid of the SAC control system, planning becomes a cooperative venture of man and machine. Each works in the areas best suited to temperament and capability, the machine handling masses of data, the man evaluating selected data and making decisions. The many abilities of the system will relieve planners of time-consuming tasks. It will store the emergency war order, weapons inventories, support capabilities, weather reports, alternate plans, and many other pieces of data. Data retrieval is accomplished rapidly and accurately, and in some cases can be accompanied by machine analysis of the retrieved data. The computer capability will provide planners with assistance in such areas as option structure, target and penetration analysis, and missile trajectory computation. The system will further assist planners through its ability to print out requested data for individual assessment, or to display the data by optical projection on screens. By means of the SAC control system, planning tasks will be completed with far greater efficiency than in the past. Vast quantities of data will be processed automatically and accurately. Wall screens will display information to the planning staff upon request, and completed plans can be pre-stored and held ready for instant use should an emergency arise. Once plans have been made and adopted, the problems of plan execution are taken over by control operations. Control operations activity in respect to any given plan will vary according to contingencies, from simple monitoring to full control of operations. The speed of the automated subsystems makes it possible for control personnel to observe the status of the SACC force at any given moment, or to follow each action of a war plan as it occurs. Deviations are noted within seconds of occurrence, and within seconds, corrective command decisions can be made and orders transmitted. One of the system's most useful aids to control operations is the central map display. The map display, using the computer-fed group display generator, gives control personnel a continuously updated picture of SACC activity. Maps of many areas may be called up instantly upon request. A grid overlay may be added. Symbols from the group display generator show changing information, such as threatening weather fronts and movements of missiles and aircraft. On request, aircraft are shown in their correct present locations. Point of departure, present location, and destination are clearly shown. Static locations, such as SACC bases and cities, are shown by transparency projectors. Targets are represented by these symbols. The effectiveness of an attack can be demonstrated by additional symbols, showing partial or total destruction. Contingencies may force decisions to change commitments after plan execution is underway. In this event, descriptive data collected from widely varied sources will immediately provide a selection of alternate plans or data for decision-making, enabling the command personnel to decide upon a new course of action. Beside monitoring actual events, the SACC control system is able to simulate tactical situations for training purposes. For example, an exercise can be devised during which SACC will appear to be engaged in a war. As if in actual war, there will be an intelligence buildup, an alert, a launching of the force, and the execution of plans and orders. The simulated situation will require appropriate decisions and actions of all personnel. Should an actual emergency occur during a training exercise, the system automatically clears itself of simulated data. The Strategic Air Command Control System, Project 465L, with its automated subsystems, provides the nearly instantaneous command and control system needed to operate the forces of the Strategic Air Command under any emergency in the decade ahead. The alert signal goes out. All data concerning the emergency is automatically processed. Displays provide the control operations staff with a constantly updated picture of the emergency situation as it develops. SACC is on the alert, ready for instant action. In peacetime exercises, as in the ever-present possibility of actual war, the automated SACC control system is designed to assist the Strategic Air Command in carrying out its mission.